Hey again, Mr. Allred. Got a ratio test here for converging series. So, once again, we're trying to tell if a series converges or diverges. We haven't been able to really tell what they might add up to be. We'll get this infinite series A. And what we're going to do is we're really going to kind of check and see if it resembles a geometric series. But it's called the ratio test because what we're going to do is we're going to take the ratio of two consecutive terms in that series. So don't get this confused with the limit comparison test. The limit comparison test compared two different series. This uses one series, but it takes two consecutive terms. So in theory, this could be like a to the 100th on the bottom and a to the 100th and first on the top. So if we wrote out our series forever, we'd just put a box around two terms and create a fraction out of them. But if we pick any two specific terms, that would probably cause a problem because the series can behave differently in the beginning than it does in the end, or it might jump around for a while and then kind of level out later. So we're taking it as we go to infinity. So basically, if these two consecutive terms, this ratio, is less than 1, then it's more or less becoming a geometric series with a ratio less than 1. Now, it might not have a consistent ratio, but it does have a ratio that is getting smaller. So that would make it converge. And similar, if it gets you a limit that is bigger than 1, then you have a divergent series. And if you get something that is 1, then you really don't know because it really kind of comes back to how small that term is getting, not necessarily how they compare to each other. So let's see here. Let's just pick a problem from the book here. So this is from 10.5, page 602. Let's go with the first one. So in this one, we're trying to figure out if 2 to the n over n factorial converges. And we're going to use the ratio test, so we're going to compare it to a generic term to the next one. So we're going to replace both of these n's with n plus 1. So that means when we do that, the next term would be 2 to the n plus 1 over n plus 1 factorial. So now we've got the a to the nth term on the bottom, which is any generic term, and then we got the following term on top. So we've created that ratio of two consecutive terms. So we got a fraction over a fraction. We'll keep change flip. So what we see here is a little bit of, not magic, but playing around here. 2 to the n plus 1. Well, if we think about how our exponents, properties of exponents work, 2 to the n plus 1, that would be 2 to the n times 2 to the first. So we can, the addition of the exponents means that the bases were multiplied. Okay. And that's going to allow us, after the keep change flip, to mark out a 2 to the n on top and a 2 to the n on bottom. And then our n plus 1 factorial, remember a factorial multiplies that number by every number less than it. So we can separate the n plus 1 term and say it's multiplied by n factorial. Okay, so that's how we can break down the n plus 1 factorial. So in that case, we can mark out the n factorials. So what's left is the 2 on top and the n plus 1 on the bottom. So in that case, as n gets really, really large, as the denominator gets large and the top stays the same, the terms, or the ratio of the terms, goes to 0. So that means that if you keep looking at two consecutive terms, it's getting smaller and smaller and smaller. So in that case, that was from the ratio test, something less than 1. So it converges. Let's scoot up and find one that diverges. Maybe one that's a little bit neater. Okay, let's look at number 6. So 3 to the n plus 2 over a natural log of n, does that converge or diverge? Well, we'll use the ratio test. So replace all the n's with n plus 1. So that's 3 to the n plus 1 plus 2. So eventually that's 3 to the n plus 3. But we're just going to let that extra one kind of fall off to the side. And natural log of n plus 1. So let's see what happens here. Keep, change, flip. So 3 to the n plus 3. Well, we can separate one of those 3's and go back to n plus 2. So we can get 3 to the n plus 2 to cancel out. Now we've got 3 natural log of n on top and a natural log of n plus 1 on the bottom. So both of those things get large. The question is, how fast do they get large? So if we looked at that, that means the numerator's going to infinity, the denominator is going to infinity. That's a good case where you could use L'Hopital's rule. So derivative of the top gives me 3 over n. Derivative of the bottom gives me 1 over n plus 1. Another fraction over fraction, keep, change, flip. 3n plus 3 over n. We could look at that as either do another L'Hopital's rule, or we could look at it as the horizontal asymptote of a rational function. But anyway, it's going towards 3. 3 is bigger than 1. So that means that basically every following term is getting approximately 3 times the previous one. So that means it diverges. Let's see here. The rest of these look a little bit long to explain, but if you have a question about any of them, let me know. But all you're doing is checking how one term changes to the next and determining what that ratio would be. So let me know if you need help.